Start.
Hello everyone, I am Harshit Syare. I am pursuing third year in Electronics and Communication Engineering in IIT Roorkee, and this is my project titled Nutrition Calculating Scale using Wireless Interface.
And hi, I am TIADC. So this is the basic block diagram of how we have done this project. This is the input weight which is sent to the strain gauge, which is load cell, which converts strain signal into the electrical signal, which we have amplified and converted into the digital signal using an ADC. And then this digital signal is fed into the microcontroller board, where we have used here is BeagleBoard XM, which is then transmitted to the remote PC, where the nutritional value of the particular object is calculated. We have used this load cell. For the load cell, we have dismantled a digital weighing scale from the market, which is load cell consists of a strain gauge, which is basically a transducer, which converts our strain signal into the digital signal. And the signal which is produced by the load cell is very minute, so we have to use the amplifier.
Okay, so now as we know, the voltage signal, which is a very small analog signal, which is now it is a very small signal, it needs to be amplified. So for amplifying, we use an operational amplifier, and using the ICs OPA 4228, and we have used the RF by R1 ratio equals to 2000, which will give us the gain of 2001, and this is the circuit diagram. Now the amplified voltage signal is then fed. Now it is an analog signal, and the microprocessor cannot process the analog signal, so we need to convert it into the digital form. So for converting it, we have used the ADC, which is TIADC 0809, and this is the connection diagram in which we have connected the VCC, ground, and all other stuffs. And we have now in this. Now let me explain it using its pin diagram. So this is its pin diagram, and as we can see, it is having address A, address B, address C. It is to select which input line we are selecting. So we have selected IN0 as an input line, and we are getting the output at these 8 bits. So this is basically 8-bit digital output, which is then fed to the BeagleBoard XM in its digital pins. One more thing I would like to explain about this. About this op-amp, and this is the circuit diagram. It contains it is a high precision operational amplifier which contains 4 op-amp, and this is its diagram. Now let us focus on BeagleBoard XM. Now the amplified 8-bit signal after conversion from ADC is now a 8-bit digital signal, and this is the information which we need, and it ranges from 0 to 255. Now this is fed into a digital input pins of the BeagleBoard XM, and now it will process it. Basically, we have kept a C++ program inside this BeagleBoard XM, and what happens in this program is that now the range is from 0 to 255, and we have multiplied it with a suitable conversion factor, which will convert it into the exact weight. And then after, we have connected a Wi-Fi module to the BeagleBoard XM, and it will transmit that signal to the remote PC. So
after receiving the file from the BeagleBoard XM, we are calculating the weight from this wireless interface. In this, basically, I have used MS Access as the database, and macros and coding in the Visual Basic to make this user interface. So this is the code for the user interface. Basically, it is just After receiving data from the BeagleBoard XM, our main aim is to calculate the nutritional facts in the particular food item. For this purpose, we have made a database in the MS Access and used Visual Basic language to code it. And for this purpose, we have assigned the macros in MS Excel, and this is the code to calculate the nutrition. What it does is basically extract data from the data file as well as from the MS Excel file, and multiplies the data into the particular calories per gram which we have stored in the MS Access. Then it simply shows this to the MS Excel file. So let us give you a demo for that. So
yeah, see, now if we suppose if we weight this apple, and so we will keep it, and now this as we have explained, this will the signal will be amplified, and this is this BeagleBone XM, what it is having a C++ program which runs in the loop, and it is continuously executing, and we have programmed it using Minicom software in the Linux. We have connected to a Linux and then programmed it and kept a C++ file inside it. So it is continuously running. Now it will send the particular signal using Wi-Fi module. And
as you can see now, if I click on the show button, it will ask for please enter food name to get the total calories and other thing. So I'm writing here apple, and then I'm pressing enter. That is giving the total calories, total protein, total fat, total carbohydrate in that particular amount of the apple, whichever the weight it is. Now let you show for another object which is banana.
Yeah, so similar as earlier, we'll keep banana on the weighing scale, and using the same process we'll obtain the required result in.
Okay, for this purpose I have to write banana. Okay, yeah, this is the total calories, protein. As you can see, they are different because weight is different and total amount per gram are different. So this is our purpose, and we have achieved it using the interface.
Yeah, so now finally, as we can see, is that we have made this program for 50 items, but we can extend the list, and if it is optimized properly and proper system is used, then we can use it for the commercial purposes as well. Thank you.